Hello students, we will see now tautomerism today. What is tautomerism and how tautomerism occurs? First of all, we will see condition for tautomerism and what is the technique for tautomerism and how tautomerizable hydrogen is identified here. We will see O double single hydrogen. If hydrogen is placed at this position, O double single hydrogen, then this hydrogen is called tautomerizable hydrogen. We know that place is important. Place where hydrogen is present here, it is called tautomerizable hydrogen. Otherwise, another place like this hydrogen is on another place. Here, single hydrogen. This hydrogen is not tautomerizable hydrogen. When you see O double single hydrogen, then it is also not tautomerizable hydrogen. We will know that place is important. When it is on this place, then it is called tautomerizable hydrogen. In double bond single hydrogen, then it is also called tautomerizable hydrogen. In triple bond single hydrogen, then it is also called tautomerizable hydrogen. Tautomerizable hydrogen where found in at this place, then it is called tautomerizable. Otherwise, it is not tautomerizable hydrogen. Like this. If three single bonds are present, if only one single bond is present, then it is not tautomerizable hydrogen. It is this place. This place is important. Then this hydrogen is tautomerizable and it takes part in tautomerism. And it is called tautomerizable hydrogen. We know also conjugation. Conjugation, what is conjugation? Conjugation means conjugation is also considered as it is a condition for resonance. Conjugation is mainly of three types: normal conjugation, extended conjugation, and cross conjugation. We know that normal conjugation is double, single, double, and extended conjugation is single, double, single, double, single, double, this like. Uh, you can consider single double is tail of monkey, tail of monkey, like tail of monkey. We can connect from back side, not from front side. So this is double single double. 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 This one is called normal conjugation. This one is also called normal conjugation, normal conjugation, normal conjugation. Whole system is called extended conjugation. Whole system is called extended conjugation, right? O double here we consider. First of all, we can see that here O double single hydrogen is tautomerizable hydrogen. And this one is also called O double single double. This one is conjugation. Double single double is conjugation. Again conjugation, again conjugation. You can conjugate here many more times as you want. And lastly, single hydrogen. So this hydrogen is also considered a tautomerizable hydrogen. This hydrogen is also considered a tautomerizable hydrogen. This hydrogen is also considered a tautomerizable hydrogen. Tautomerizable hydrogen. You can see here this one. O. H A H B H C H D. You can assume HB. Here HA is considered a tautomerizable hydrogen, while HB is not considered a tautomerizable hydrogen because we consider here O double single hydrogen can be tautomerizable hydrogen, can behave as a tautomerizable hydrogen, but O double single hydrogen cannot behave as a tautomerizable hydrogen. So HB is not tautomerizable hydrogen, HC is not, HD is not, but AC is tautomerizable hydrogen. Why? Because place is important. Hydrogen is not important. Here, place is here this place is of tautomerizable hydrogen. So this hydrogen takes part in tautomerization, right? This one. Let us consider HA, HB, HC, HD, and HE. O double single hydrogen. HE can be tautomerizable hydrogen or not. But we know that this HE is O double single hydrogen like, but this hydrogen is vinylic hydrogen. Vinylic hydrogen, and this vinylic hydrogen never takes part in tautomerization. Why? Because of continuity of double bond. What is continuity of double bond? We will see later in mechanism of tautomerism. But here we only consider here if hydrogen is of vinylic position, then it will never takes part in tautomerization. If it is allylic position, then it will take part in tautomerization. What is allylic and what is vinylic? Here we will see here. Suppose double bond A CH2 CH single bond H. This one is called vinylic hydrogen. Vinylic hydrogen because this carbon is called vinylic carbon. This is called vinylic carbon. And if a CH2 double bond CH single bond CH2H, this hydrogen, this carbon is called allylic carbon, and this hydrogen is considered as allylic hydrogen. Vinylic hydrogen never participate in tautomerization. Never participating. Suppose here, how can you memorize here? This one is called Vimal Pan Masala. This one is called, you can heard in add Vimal Pan Masala. It is very famous. Vimal Pan Masala. So VI, this is called vinylic. Vinylic. And one carbon later, it is called allylic. This one is one carbon later. This M enters here after vinylic. It is called allylic. Vinylic, this one, and allylic, this one. Vinylic hydrogen never participate in tautomerization. As you see here, this one. Suppose this like H, 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 H. A, B, C, D, and E. Here HA, HE is on this place, single hydrogen, but never participate in tautomerization because HA and HE are vinylic hydrogen. And this vinylic hydrogen never participate in tautomerization. This HB never participate. Why never participate? Because it is not on the place of this place. O double single hydrogen. This, as we know that this hydrogen never participate in tautomerization, so this will not take part in tautomerization. But this one is like allylic hydrogen, and this fulfill the condition. This like O double O double single hydrogen. So this will take part in tautomerization. Tautomerization, what is tautomerization we will consider here, but how tautomerizable hydrogen we see here, this is only condition O double single hydrogen. More electronegative element, then multiple bond, then single hydrogen. Okay. Another is like a bridgehead. This one. Bridgehead, what is bridgehead is of two types: bridgehead without carbon and bridgehead with carbon. This one is uh, we will consider here. This one is bridgehead with carbon. Suppose these are banks of a river, and this is a bridge, and this one is bridge, like bridge. Here we can move from this path, so it is called bridge, and this point is bridge head, and this is bridge. This one is bridge, and this one is carbon, so it is called bridge head with carbon. And here, this one, double bond O. This one is also bridge. This is called bridge head without carbon. This is also hydrogen. As we know that on a bridge head, this one, on this bridge head, what type of bridge head here? Bridge head with carbon. In bridge head with carbon, double bond is never present on bridge head position. Double bond will never present on bridge head position. Why? Because this will this on this position, if it present here double bond, then sp2 hybridization arises, and sp2 means what? There is a planarity. Planarity. Planarity means system goes in same plane, but here this one is out of plane, and this bond breaks down due to a strain. A strain break down the system, and the system vanishes. So here sp2 hybridization on bridgehead never possible. So if here double bond is present, then it will vanish, it will break down. So here double bond is not possible. But in bridgehead without carbon, but a bridgehead without carbon, but here bridgehead without carbon. sp2 hybridization, sp2 hybridization or double bond can be present on bridgehead position, like this one. This one is correct. This one is also correct. But this is not correct because here a strain break down the system and it will vanish this. So this is not, this one is not possible because on bridgehead double bond is not possible, never possible. This one is not possible. This double bond is allowed because this double bond is not present on bridgehead position, right? So we will consider here vinylic hydrogen will not participate in tautomerism, and bridgehead with carbon, bridgehead hydrogen will not participate in tautomerization. If it will participate, it will break down. Then it is not possible. Then we take some example. O double single hydrogen. This will show the tautomerization first. Second main, this one double bond O double single hydrogen. Isotoperization occurs. Here tautomerization is not possible because it is not on position of O double single hydrogen. O double single hydrogen. This will also not participate in tautomerization because it is on the bridgehead position. Bridgehead position. And what type of bridgehead position? Bridgehead with carbon. 5. This one, double bond. This hydrogen is a bridgehead position, but it is of bridgehead without carbon. So it will take part in tautomerization. Another example is this one. This hydrogen will take part in tautomerization, but this one is not take part in because of vinylic hydrogen. This one is also not take part in because of vinylic hydrogen. Not take part. This one is vinylic hydrogen, so not take part. This one is also vinylic, but this one is allylic and fulfill the condition of O double, single double. Our condition is this one, single hydrogen. So we'll take here. This hydrogen never takes part. This hydrogen never takes part. This hydrogen will take part or not. We will see here. O double, single hydrogen. So this will takes part in single hydrogen. O double, single hydrogen. So this will takes part in, and this one is O double, single hydrogen. So this will takes part in tautomerizable hydrogen. This one. This one is also tautomerizable hydrogen. This one is also tautomerizable hydrogen. But this one never takes part. This one never takes part. This one is also not able. Right. We'll see here how can we see the tautomerizable hydrogen and what is the technique for tautomerizable hydrogen. But first of all, we'll see definition of tautomerizable hydrogen. What is definition of tautomerizable hydrogen? Then we'll see here tautomerizable hydrogen. Tautomerization. Delocalization of pi bond. Delocalization of pi bond with migration of at least one atom or hydrogen. This process is called tautomerization. Suppose A tautomerizes here and converts into B. Then equilibrium sign here, we will consider the equilibrium sign here. And this one is called, uh, this is in dynamic equilibrium, not in static equilibrium. Equilibrium is of two types. One is dynamic and another is static. Here, so tautomerization is also called desmotropic. Desmotropic. This one is also called desmotropic. And in this process, there is a migration of H plus. So it is also called prototropic. This is also called prototropic. The name of tautomerization is desmotropic or prototropic because of there is a dynamic equilibrium between these structure and there is a migration of H plus in this process, so it is called prototropic. So there are another name for tautomerization also. Then we see here how tautomerization occurs. So for tautomerization, it is of two types. One is acid catalyzed tautomerization. Acid catalyzed tautomerization. Another is base catalyzed tautomerization. Acid catalyzed means acid in presence of acid will uh, occurs, and base catalyzed means in presence of base catalyzed it will occurs. So first of all, we see here acid catalyzed tautomerization. Acid catalyzed tautomerization. Acid catalyzed tautomerization. See here how acid catalyzed tautomerization occurs. First of all, we see here this one. Representation of acid is like HA, and this one, this lone pairs is ERS. And what is the function of ERS? ERS loves with H plus ions. ERS having tendency to love H plus ion. First priority is to trap H plus ions. So this will take part from back side, from anti-bonding side, and this bonding goes on more electronegative. So this double bond O H plus this one. This is called acid-base reaction. Why acid-base? Because this ERS trap H plus ion, and this H plus ion goes on this acid-base reaction. This one is called base, and this one is called acid. But remember here, it is a catalyst. HA is catalyst, right? Then this one is A minus is present here in the solution. And this hydrogen, which is like a tautomerisable hydrogen, this hydrogen, A minus trap this A, and this goes on this like and this one. We know that this is acid-base reaction, so equilibrium is formed here. So equilibrium is formed here. This is also called acid-base reaction. So equilibrium is also formed here. So we can see here O H double this. This one is the family of keto group, and this one is family of in. This double bond is like in, or this OH is all. So this is called enol form. Keto and enol form. Keto and enol form are on dynamic equilibrium like this. Like this. This one is keto and this one is enol. And HA removes here this HA and this HA. As he goes, comes and at is removes here. HA like HA goes like HA and removes like HA. So HA behaves as a catalyst. And this one is called acid catalyzed tautomerization. Another is base catalyzed tautomerization. How can see base catalyzed tautomerization? Base catalyzed tautomerization. This one. This one is base. B minus. Representation of base is like B minus. And this B minus trap this hydrogen because this hydrogen is in effect of minus N. This group is of minus N. So this hydrogen is acidic, and this hydrogen is acidic, and this traps H. So there is a O minus 6. And as we know that it is acid-base reaction, so equilibrium is established here. And this minus charge is in resonance. So resonance occurs. And this one, H plus ion, this is BH. BH. So this H traps, and this is OH, and this is double. What you see here, we'll see here this hydrogen is acidic because it is in effect of minus N. So this is acidic, and this one negative charge resonance occurs, and this one again acid base reaction occurs. Finally, only acid base reaction occurs and resonance occurs here. So it is called base catalyzed tautomerization. And base catalyzed tautomerization is what? Base comes and trap those H plus ions which are in effect of minus M group. Uh, minus M group means like C double bond, like C triple bond N, like NO2. This one. This it has effect which makes the hydrogen more acidic. And B minus traps this H and negative charge arises here, and this one is OH. This is called enol. This is called keto, and this is called enol. What is the difference between these two? We will see here. Why we will take acid catalyzed and base catalyzed automerization. We'll see here. But first of all, we see the acid catalyzed and base catalyzed in terms of mechanism. What is the mechanism? How it shows here? Right. Then see here how tautomerization occurs. It is in two conditions. One is acid catalyzed and another is base catalyzed. But we will see here normally like this type CO, CH2H, and this one is CS3. This one hydrogen is, and we will take participate. This hydrogen goes to more electronegative element. This one is equilibrium sign arises and CH3, COH, and this one is double bond single. This is enol and this is ketone. Another example you can see here. This hydrogen, and this hydrogen seems to be tautomerizable hydrogen, but HA, HB, and HC. HA seems to be tautomerizable hydrogen, but it is not because it is of vinylic character, vinylic position. First of all, we see how tautomerization occurs. Then, if we want to participate this hydrogen in tautomerization, then we will this like this falls this falls on bond and this goes on this line. What is the structure here? This one is double bond, OH, this line. A continuous double bond is never present in a smaller ring because when continuous double bond is present, then sp hybridization occurs and bond angle is 180 degree and strain will be very high. If strain is high, then system goes dies. Strain is very bad thing. If it arises in anything, human body, in our species, in our organic molecule, then it will not exist. It will vanish. So sp hydrogen is not possible in a smaller ring. A smaller ring means what? A smaller ring means 3 to 7. This one. Or larger ring means more than 8. In larger ring, continuous double bond should be present. It may be present. But a smaller ring, it never be present because of high strain. High strain vanishes the species. So this hydrogen, if takes part, then it will die. So this hydrogen will not take part in tautomerization. But see another thing like this. If this hydrogen takes part in tautomerization, then how this will goes, and this will goes. There is a equilibrium sign, and this one is OH, double bond, double bond, double. This is equilibrium and this goes in. There is no strain, no any bad things here. It is aromatic species, which is like which is like God Krishna. Krishna having Sudarshan Chakra and it also having Sudarshan Chakra. This one is like this one, Sudarshan Chakra. So it becomes very stable. Like this one, this hydrogen will take part in tautomerization. So this goes this way, and this way. There is equilibrium sign here, which double bond, double. This hydrogen will never participate in resonance in tautomerization because this is vinylic and this can takes part. So we can see we can write here this one. Wait, see, this way. 1, 2, and 3 here. 1, 2, 3 here and 3 here. Tautomers of each other. एक दूसरे these are all tautomers of each other. Then this one, this line, double bond O, and this hydrogen and this hydrogen. O double single hydrogen, O double single hydrogen can take part in tautomerization, but this one is not because this will goes here and this will be this way. Then we consider here this slide double bond which this one. Here strain highly there is a high strain on this because of planarity. If system is non-planar and we you make this planar, then it becomes unstable. Our nose is non-planar, and if you press your nose and make this planar, then what does we get unstable? So this instability is not this instability make it very unstable. So this one is a very unstable system. So this will not participate in tautomerization. If any hydrogen takes part in tautomerization and system get unstabilized, then that hydrogen will not able to take part in tautomerization. But this hydrogen will take part because of this, like this. This one. There is no any instability here, so this hydrogen is able to take part in tautomerization. Right. Another example is like this. This hydrogen also takes part in tautomerization. This way. See, this will take part in tautomerization because we have O single, double, single hydrogen. So this will take part in tautomerization. and this like tautomerism occurs. Right. This hydrogen is also called tautomerizable hydrogen because this having bridgehead without carbon. So this will goes like this, and this will go this one. Wait. This one is keto in our tautomerization. This hydrogen is also tautomerizable hydrogen, like tautomerizable hydrogen, but this goes this side, and this one goes this double bond, waits, double. This one is anti-aromatic. Anti-aromatic. Equilibrium will not shift this side because this anti-aromatic makes it very unstable. Okay. हाँ? चालीस मिनट हो गए तो ब्रेक हो गया होगा